Hi, my name is Matthew Moderman, and this is for CS 499, the capstone for computer science through SNHU Online. For the capstone, our job is to create an online e-portfolio through Git. And to start that, we're supposed to do a code review. To get everything started, we were given a guideline for our code review. Um, it breaks down how we're supposed to express all the different parts. We're supposed to give three different examples of what we're able to do: one for software design, one for algorithms and data structures, and one for databases, using databases. So this was the breakdown for the rubric for the code review that I'm currently doing. This is just an intro. I know that most of this is probably going to be overdone, but I want to make sure we get everything in the proper hands right now. Using the final guidelines, I went through and looked at the possible courses to be used for the software design and engineering, the algorithms and data structures, and then for databases. Going through all of the old folders that I had kept, I decided to go with CS 330, Computational Graphics and Visualization, the final project for that. I also decided to use CS 260, Data Structures and Algorithms, and then to use the final project from Advanced Programming Concepts from CS 340. Before going over each of the projects from previous courses showing the different ideas, I just wanted to go over the checklist that was given to us for our course. The idea is to have a structured environment background to understand what was produced and to increase its efficiency and logic. So the way it's broken down is it has the main sections: structures, documentations, variables, uh, arithmetic operations, loops, branches, and defensive programming. By going through this checklist, we're able to make sure that everything is as efficient and logical as possible. Within the structures section, we're looking to make sure that everything meets standard, is well styled, make sure that it is well stated and easy to understand. Underneath that, for documentation, we're just making sure that we're explaining it as we go. Maybe put some README files within them just so that everything can be understood for a new programmer looking through everything. We want to look over the variables to make sure that they're clear, consistent, make sure that we have the same kind of naming styles. That way there's no confusion. For the arithmetic, we are making sure that all the proper data types are being used. That way there is no issues. We want to make sure that nothing is being divided by zero, simple arithmetic operations. Within loops and branches, we want to make sure that everything does come to an end, that there's a default, that once we enter into a loop or a branch, it will exit, that conditionally it will exit regardless. And as far as defensive programming, we are just making sure that there are no loose ends, that everything is being assigned properly, and that everything will be taken out properly, that everything is being checked so that we know that it is there before we try to access it and end the program. So that is an overview of the code review checklist that we're going to use as we go through the different projects in my previous courses to show the different skill sets. To go through everything, the first thing that I did was I went through my old course files and I pulled out the final project files. So take a look right here. I have the three different final project files. The first one we were going to look at was for software engineering, so that was the CS330 project. We're going to open this up and take a look. Right off the bat, the first thing that I see is that the filing system was pretty poor on my part. I've got a few different things going on here. Now, I do have my dependencies easily situated, and I know that this is the actual final project, but in here, these two, Animation and OpenGL, these were other projects I had worked on, so right off the bat I know I'm going to have to go through and check to see what can just be taken out of the final packaging for the filing system. Within the file for the actual final project, I open up here and I see the solution folder, and that'll bring us to the actual source code and all the relevant files for the project. So I'm just going to expand it here, get a better look at everything, kind of pull this off to the side. So for the final project for CS330, we were supposed to make a 3D visual model graphics. So we started off by picking a simple object. I used a glass cup, and then we had to render it, draw it, texture it, and light it. So before we go into the actual code and go through the code review checklist for this project, the first thing I'm going to do is make sure that the file builds, and we're going to run it without debugging. I want to see if it actually works. So the first thing that I see is that it does open up. It is showing what was created, but it was a little small. It didn't actually fill the screen. So we'll review that. But for right now, what you can see is that it is a three-dimensional model that started off as a cup. The texture that I used was actually one that was given to us by the professor, and I just wrapped it around the cylinder. It's comprised of multiple pieces. I have the body of the cup as one cylinder, and then I have a triangular fan at the bottom to create the indent. With that, I have two light sources, one here and one on the other side. One is portraying green, the other one is red. But as you can see, even as I'm moving this, I'm able to orbit it. I am able to zoom in and out. So I am able to control it with different keys. So that is just to show that at least something is working right off the bat. As we go back to the source code, we're going to start off by looking at the structure of the source code. You can see at the top we start off by including everything that's needed. So right at the top, easy to find. We're still using namespace standard. I start off by including some variables, the peripheral function inputs, camera attributes. What you'll see is that I'm trying to keep things together. It's not necessarily in the best order, but I am trying to keep everything together. The shader functions, creating the project program object, and then we go into our actual main method where we create the window. Jumping around here, sorry about that. Set the callback keys for us to be able to manipulate the output, and then we actually start to create the cylinder. Then we define the bottom, that was the triangular fan at the bottom, and then both of the light sources are made from cubes, so that includes the vertices, the indices, and the positioning. So that way it creates a cube. Then we go into our VBO, EBO, and VAO. Everything, once again, just kept in order. Easy to see the logic. Try to create some space in between everything to make it easy to read. As far as documentation, as we're going through this, you'll see I try to put comment at the beginning of each section, but I also added some comments within it. Some of it might be overdone for the fact that this was for a project for class. I might have over-explained some things, but better to over-explain than under-explain. This is a header for everything that needs to be sent to the shader source codes. You'll see I did that in a couple of places. Everything for the VBO, EBO, VAO, just to kind of keep everything in order. Is it the best structure? Not sure, but for this, it keeps everything set. Keep going down. We go into the while loop while the window is open, while the window is not closed. Here is where we actually get the buffer, clear everything. We create the matrix for the different views, the model, the view, the projection, and then we create everything for the lighting. Trying not to scroll in between so that it's easy to read along. And then at the bottom, we unbind and clear everything out right here. Clear GPU resources for both objects. And the last thing that I have down here at the bottom is defining the callback functions for the different keystrokes, the different ways of manipulating the view. So everything is structurally set up to make sense. Probably could set it into different files and call that through the main application. But for right now, it's at least structurally sound. The documentation, once again, I have comments for everything. We can check those to see if anything needs to be reset or made a little bit easier to read. We can also add the README file. The variables. Overall, most of these are pretty self-explanatory. Is panning is used when we're panning. Is orbiting is used while we're orbiting for the booleans. Some of them are a little ambiguous and probably can be redefined. Right here at the beginning, you see I have width and height. This was actually used for the size of the window, but if you just look at that, you're not sure where this is actually going to come into place until we come across it or if you go searching for it. Arithmetic operations, I did not find anything that was questionable. Not to say that there isn't. I should go through and double check again, but I did not find anything off the bat that should be worrisome. Loops and branches. Within the main while loop, you'll see while the window is closed. So unless the window is never closed, this will eventually terminate. As far as for loops, while I was developing the objects, you'll see that I use finite for loops that were already set. These numbers are based on the indices that are needed to create the objects. Now, we could create variables that hold these numbers and that are placed in so that the number is not set randomly or seems to be random, but it does at least finish out the for loop. So all of the branches do close. Defensively, I do not have any test within this. I don't have anything to make sure that the texture file is there when I am using it. So I have nothing to check whether or not the texture file is going to be there when we load the image. I don't have any try catches as far as making sure there are no errors, anything out of bounds. Now granted, since this is a single program that is not including any inputs other than the peripherals, it should be okay, but that's something to evaluate and to go over. So that's the structure, documentation, variables, arithmetic, loops, defensive programming. for the software. I do need to do some work on it. I do need to find an enhancement. So I would like to, I'm going to run this kit real quick just so you can see. I would like to make it so that it sets to the entire screen. I would like to fix the lighting. The math seems off. It doesn't seem like it's coming from the proper place. I'd also like to look into creating a floor so that the object is standing and I am actually moving. My view is moving through the object instead of being able to orbit all around. Maybe I'll take the fan down here at the bottom and put it at the top as some sort of roof just so that you can see it, but just some adjustments to showcase differences. The second project that I am going to use to show algorithms and data structure comes from CS260, data structures and algorithms. So with this, once I bring everything up, I will improve the efficiency and expand the complexity. Right now I have a series of, well, actually I'll show you. Let's get rid of this. I have a series of files that are different algorithms. This project was supposed to take information from a bidding site, I'll just show you right here, as a CSV file, and through different algorithms, sort through the information, give insightful outputs, and then also show how long it took to sort through the information. So what you'll see here is I have a binary search tree, I have a hash table, linked list, vector sorting. All of these do basically the same thing, and it's just to show how long it would take, the difference depending on the data structure, the algorithm, and what we actually need to accomplish. So I'm just going to open one of these to actually go through the review checklist. They're basically all the same except for what is actually how the algorithm and the structures are set up. But you can see the information from the review checklist here. So first off, you'll see that the documentation is a bit different. Some of this was given to us to start, and that's why it's written out the way it is. You'll see I actually did this one over a year ago at this point. But same ideas. I've got everything included at the top that would be needed to run it. We then start off with the different structures, in this case for a binary search tree, the nodes that are needed to hold the bids, real simple laid out, internal structure for the tree. We then go into the class for the binary tree that gives me functions to add, put them in order, remove from it. I have my default constructor. We have a search, add node, display bids. All of this is based off of the CSV file that I showed you earlier. And then there is a main function that goes through, prompts the user, gets the information, goes into a while loop while we can choose what to do with the information. We then go through the different cases and show how long it takes. Overall, the information is pretty easy to follow. The documentation, as far as the comments, are easily laid out. The variables are very direct. Don't really think they need to be changed up at all, but it can be reviewed as I'm going through this. There's no real arithmetic in this one, so we don't have to worry much about that. When I package everything together, we will probably do it as a main file that uses the different functions, and we'll call the different functions or the different classes. So that's probably how it's going to be laid out to expand its use. The loops, the main loop is this while loop that goes through different options and only exits when the input is 9. As far as defensive programming right off the bat, there's no try catch on that, so that should be checked in case there is an unforeseen input. So as far as defensive programming, and the deallocation, that was one thing that I did see right off the bat. Where is it? We create in this a binary search tree, but it is never deallocated from what I can see. So we also create new nodes. So as far as that goes, we got to make sure that everything is deallocated at the end, so that we don't overflow. So once we create the main function or the main function and add this into it, calling the different processes, the different algorithms, we'll be able to show the different time it takes for the different algorithms and the different structures, showing that I am able to package it properly, be defensive about the deallocations, and I do need to make sure that all the loops and branches work properly. Alright, so for the last project, we needed to showcase databases and our use of databases. From the list that we had, I chose to go with CS340 Advanced Programming Concepts. So down here, I needed to find out how I was going to enhance it, and what I will do is incorporate more data mining as we go through. But let's start off by opening up what is already here. So you'll see I have my CS340 project. I open the files, and everything is done in Python. And we're going to open this in Visual Studio just to make it easier to read. Alright, so what you'll see is what we used was MongoDB as far as a NoSQL database. That way we can structure things more fluidly. I already went and downloaded the information that I had to parse through using Python and JSON for the MongoSQL. As you can see, it was a series of stocks. Each line is a different stock with its own unique ID, ticker, lots of different information, but it's not all the same. It's not fully structured. So that's why we had to use MongoDB instead of a regular SQL to search through everything. I'm going to close this out. I don't think we need to look at that again. But in the project, we had to write how to create a document and put it in. We had to write how to delete a document from. We had to write how to update a document with different key values. And we also had to write how, which one did I miss? Read. Oh, read. I'm sorry. For the read, though, I have different kinds of reads depending on what information was being sought. So there are quite a few different ones. In the end, the last thing we did was we created a REST service API so that way we could look over everything from one place. Now, I'm going to pull over. We did this all through Codio. I'm going to pull this over so you can see. This is a terminal that is on a different machine, but you'll see that all of the resources are listed here that had been created. I'm also going to pull up my final project paper just to show you that as I went through how we actually processed through this, we had to pull up the shell, and then we could get into all the different databases, and then I was able to use the different files to actually see everything. Now, the purpose of what we're doing right now, though, is the code review. Some of this out. I'm going to start with just create document. You can see that each of the documents is short on purpose so that it's easy to see and easy to call within the terminal. Then I would call the Python file to be able to do the different functions with the stock database. But as far as structure, I kept everything short. I did use try and catch and exceptions wherever I felt it was plausible. I think the names are very easy to understand. It could use some documentation to go along with it, some commenting, but for how short it is, it's pretty easy to parse through. There's no major arithmetic issues because there's not a lot of arithmetic that's actually in place. As far as loops and branches, once again, the loops, there is not a lot to be seen, but that can be further explored. And as far as defensive programming, I don't see any overflows, unassigned variables, outputs that were not assigned. Should look into doing timeouts with this. And everything was finalized before termination. The big thing that needs to be done with this is I need to figure out how to package this properly because other people will not be able to get onto Codio through my information. So I'm going to need to have to figure out how to relay that in a single package onto Git. But that is the next step. So I've gone over the three different pieces, the three different projects that will be shown in the files. The first one was from CS330 for software design and engineering. This was the graphics through OpenGL, and I plan on redesigning it a bit. I did not see any major issues, even though variables should probably be checked to make sure they're not ambiguous. The second one is algorithms and data structures. That was through CS260, where I had the list of the different kinds of data structures, but there needs to be a source file for me to go in and look through everything. I also need to import the CSV file that it is referring to so that it can all be packaged together. The last one then was the CS340. This was for databases using MongoDB and JSON through Python. I need to look into expanding the functionality of this. and incorporate more data mining. Now, granted, the read function is a decent amount of data mining, quote unquote, to begin with, but it can be expanded. A lot of it is poorly written and should be restructured and commented properly. And the big concern then is figuring out how to package it and put it onto Git so that it can be viewed. So this is the direction that I am heading. This is what I'm looking over. This was a quick code review. Hopefully it is easy to understand, and hopefully I can get all of this information as soon as possible. Thank you very much for your time.